Welcome back. What we're going to do in this lesson today is continue with the lesson we previously did, solving equations with adding and subtracting. Today what we're going to do is introduce two other operations, multiplying and dividing. This lesson really could have been combined with the last one, but it would have been so lengthy. But as a result, we have duplicates in our vocabulary. Let's take a look at our first term, solving an equation. It's actually very self-explanatory. Solving an equation means simply finding the solutions to an equation. Inverse operations, again, that's familiar. Inverse operations are two operations that undo each other. When we were using addition and subtraction as inverse operations, what we did was take the positive and negative of the same number to zero them out. Because when the digit is the same, but the symbols, but their positive and negatives are opposites, they actually have a value of 0. Here what we do is with multiplying and dividing, you'll see how they work as inverse operations. And then our third and final term for this lesson, equivalent equations, which are equations that have the same value. For what we'll be doing here, that basically means each side of an equal sign. We're treating those as separate equations within one. Let's get right to our first example. Our directions are simple. Solve the equation and then check your solution. That is why I wrote the problem twice. I wrote it once because, you know me, I insist that you copy the problem from the book or from the board into your notebook or onto your loose leaf. And then I write it the second time because oftentimes I'm guilty of not going back to double check my directions after I've completed a problem. So I write it twice just to remind me that I need to check the solution as well. Let's take a look. Our goal for each and every one of these equations is the same. It is to get the variable by itself. And right now, the y is not alone. It has a -8 as a coefficient. So what's happening to the y? It's being multiplied right now by a -8. And what we need to do is apply the inverse operation. For this specifically, the way I like to look at it is I ask myself, what is the opposite of being multiplied by a -8? And in the scheme of inverse operations, that means being divided by a -8. And that's how we will isolate the y. So here's what that means. I rewrite the equation. And now what I have to do is divide both sides by a -8. I write that in the form of a fraction because you know that fractions are division problems. But I want you to see why it works the way that it works. When we divide a number by itself, we end up with a 1. You know any number over itself is 1. But by doing that, that gives us the only coefficient that a variable may have, and that is a +1. Now let's take care of the other side. We have a +72 divided by a -8. The first thing I do is write down my negative symbol because I know that a positive number divided by a negative gives us a negative quotient. And then I do the arithmetic. 72 divided by 8 is 9. So in this equation, y equals -9. And most times I would think I was done, but then I see my second equation here and I remember, oh, I have to check my work. So now, instead of writing 8y, I'm going to substitute our solution, -9, for the y. So now we have -8 times a -9. I remember my integers rules that when you are multiplying two negative numbers, your product is positive. 8 times 9 is 72. 72 does in fact equal 72. So we have proven that -9 is the solution. Example 2, we have the same set of directions to solve and to check. Here's our equation. 63 equals n divided by a negative 3. So the first thing we have to go to is, how do we get the n by itself? What is happening to the variable? And as you can see, it is being divided by a negative 3. We go to our vocabulary term, inverse operation, and we ask ourselves, what is the opposite of being divided by a negative 3? And the answer is being multiplied by negative 3. So what we do is we bring down our 63, and we are going to multiply both sides by negative 3. We bring down our n divided by negative 3. And watch what I do. I'm going to put our integer in fraction form, just so that it's balanced, it's even, it's more comfortable for us to solve. 63 times negative 3, well, I know that it's a negative number because it's a positive times a negative. And 3 times 63 is actually 189. So we have a negative 189. This negative 3 and negative 3 cross simplify, and we end up with 1n over 1, which means simplified as n, and we find out that n equals negative 189. So now what we need to do is plug it into our original equation to see if it's right. So we have 63 equals, but instead of n divided by negative 3, I'm going to substitute a negative 189 divided by negative 3. Now, any part of the equation that we're not manipulating has to be brought down exactly the way that it is. So I'm bringing down this 63. Now we have 189 divided by 3. Well, it's a negative divided by negative, so I know my answer will be positive. And if this is something that you can't do right away or do in your head, then what you need to do is write on the side, do your long division. 3 goes into 18 6 times. 6 times 3 is 18. We bring down the 9. 9 divided by 3 is 3. 3 times 3 is 9. So we find that 189 divided by 3 is 63. So once again, we have proven that our solution is right. Now, examples 3 and 4 are word problems. And here, I know that in general, most students don't like word problems. There's a lot to read. It's not easy. You'd rather have just the problem in front of you. But really, here's a real-life application for this skill. Plus, it forces you to think. A thermal ice gel can melt through ice at a rate of 15 feet per minute. How long will it take to go through 90 feet of ice? Well, I have to tell you, oftentimes when you are given or when you are reading word problems, the expression or the equation is not given to you. That's part of the thinking process, deciding how you will go about finding your answer. But what I did was, I want to show you how to do that. I have here 15m equals 90, and I want to explain why. In our story, it tells us that this thermal drill can melt through ice at a rate of 15 feet per minute. And that is expressed here. 15 feet times however many minutes there are. Now we do know that there is a total of 90 feet. And so the way to figure that out is to see by what number, by how many minutes, we're multiplying the 15 to get our 90. Right now, the m, which is our variable for this problem, is being multiplied by 15. So we have to use our inverse operation. So we have the opposite of being multiplied by positive 15 is to be divided by 15. Here we have a coefficient of 1, 1m. And I know that some of you would rather just call it M. Whether you have the one there or not is actually just a function of your comfort level. For me, both are the same. They're acceptable. And 90 divided by 15 is 6. So it would take this thermal drill 6 minutes to melt through 90 feet of ice. Now our next problem is a little similar. Why don't you listen as I read along? Sue is taking a trip. Her car has a full tank of gas. After driving 420 miles, Sue stops to refuel. It takes 12 gallons of gas to fill the tank. Find out how many miles per gallon the car got. So miles per gallon. Here is the equation that I've put together. And there are a couple different ways that you can do this. This was my equation of choice. Similarly to example 3, we have a rate. We know that she got 12 gallons of gas. We don't know how many miles she drove. We know that she drove 420 miles, and the rate would be the gallons times the mileage. So in order to find out how many miles per gallon her car got, we have to divide both sides by the coefficient 12, because you know the opposite of being multiplied by 12 is being divided by 12. Here we have created a coefficient of 1 for our m. And I'm not going to take the time to do it now, but when you do your long division, you will find that 420 divided by 12 is 35. So she got 35 miles for every gallon of gas. And our final example for today is an area. I told you they've been doing a lot of area and perimeter this year. Let's take a look. We have to find the total area of this, what we'll call an irregularly shaped figure. What we have here is a triangle and a rectangle. So the best way to tackle this problem is to find the areas separately. But I want to put up a note here to remind us of what we have to do. In order to find the total area, we have to remember that that means getting the area of the triangle and adding that to the area of the rectangle. Only then will we find the total area. So, let's start with, well, the triangle. We always start with our formula. The area of a triangle is found by multiplying the base and the height and dividing the product by 2. So we're looking for the area. Here's our triangle. Our height is 6. But our base of the triangle isn't labeled, so what do? Don't panic. You'll notice that the base of the triangle is the same as one of the sides of the rectangle. And in rectangles, you know that opposite sides, the parallel sides, have the same measurement. So the base is x, and we have to remember to divide that by 2. And here's good practice, and it's a good refresher because we haven't encountered this often, where we have a division problem that involves a single variable. Well, we divide the numbers first. 6 divided by 2, that equals 3. And then this variable just gets brought down. So the area of the triangle is 3x. Now remember, I know it seems unfinished because our final answer is not an actual number. But because one of the sides is labeled as a variable, this actually is the right answer. Just feels a little uncomfortable. Now to find the area of the rectangle. Again, we start with our formula. The length is x units, and the width is 4. And then we will simplify it. The proper way to write x times 4 is to have the 4 be in the coefficients place and x following it. So now we know that the area of the rectangle is 4x. Remember, we need to find the total area. So what do? We add the area of the triangle and the area of the rectangle, and we get a total area of 7x units squared. So a problem like this might seem daunting, might make you feel confused, but just take a deep breath, remind yourself you have all the skills that you need in order to solve this problem. You just have to take it one piece at a time, and you'll be a success.